in the section of talking about the three important, I would say, I will call it the three pillars. Okay, the three pillars of trigonometry. Okay, they are A, R, D. A, R, D. Okay, so from the outset, I wish to emphasize the importance of ARD. Okay, and this method I will be teaching you is going to be very helpful for your calculus classes and for your future programming classes as well. Okay, which I believe, okay, because I have taught those classes and I've taught programming classes before myself. And from my own understanding, you know, being through college and graduate schools, and I just feel this way of teaching you would be beneficial for you the most, okay? And once again, it's my very personal experience and my understanding and the sharing of these understanding. Okay, so we get straight to the point. Angle, right? The three pillars of trigonometry. ARD. Okay, so we make sure we understand this very well. ARD. All the questions you're going to encounter in trigonometry. Okay, so let me give you a little, like, what to expect. If you understand ARD well, you will find that all the questions you meet, all the questions you are going to solve is either from A to D or the other way, for D to A. I have not seen any exceptions personally. So all the questions you're going to encounter is either from A to D or D to A. No exceptions from my experience, provided that I've been through colleges and graduate schools. Okay, so that's how important these ARDs are. Okay, but you must be patient with yourself because this journey of doing the work this way, at the beginning, it seemed to be kind of long. Okay, sometimes we want to have shortcut. I'm not going to teach you the shortcut because I believe over time you will develop your own shortcut with all the understandings behind you. The shortcut is obvious. The shortcut is there. So some of you might know the shortcut. Okay. Feel free to ask me anything you want, but I will keep our task, our entire conversation, our entire narrative on the theme we started with, function, input, output. That's all. So we have a focus. So no matter what we do, we have a focus. Okay. Right now we are setting the stage to introduce definition. Yesterday we talked about angle. Doesn't everybody understand angle already? Okay, I got a message. I'm going to answer this. This is from the other class. Okay, so I'm going to ignore that right now because I'm teaching this class. Okay. So during my class, and I would probably not answer the questions promptly, okay, but I will get to it afterwards. All right, so now let's continue. A. Does everybody have any question about the question of angle measurement? How the angle are measured? every input for the 6 trig functions, every angle is measured the same way, okay? Reference angle is measured differently though. Reference angle is measured differently though, okay? Because it's between the terminal and x-axis. So in that regard, you know, we'll look at a different perspective. It's just a slightly different perspective. We'll get to that, okay? So now angle measurement. So now I put this is called standard position. Can you guys say the word standard position? So in your vocabulary, you're gonna have understanding of standard position. Okay, standard position. And I don't think I can put an arrow here with this software because I'm using multiple software at the same time. Okay, but you just understand this is how the angle is measurement. All the input for the trig functions, for the 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, their input, which are angles, they are all measured from standard position. So that's what I meant. Okay, and next, reference angle. Reference angle, we talk about, it has to be positive. Number 1 has to be positive. Number 2, it has to be acute. So these are 2 conditions, 2 important conditions we must honor at all time. Okay, at all time, positive, acute. Okay, between the terminal of an angle and the x-axis. So I have discovered this software which I have used. Okay, this is online material. So I'm going to share with you, and you guys, I'm going to send you the link. And so you can use that too, as just use it as a, you know, as a reference. Okay, so the people have developed these materials, and you know, I'm even thinking of make some donations to this website because the benefit is to all of us. Okay, the benefit is to all of us. So this is the website. Okay, one of the mathematicians or math teachers, he developed this. The only disadvantage I wish, okay, it's there, is that it's given us the degree. It didn't give us the degree. It didn't give us the radian. I would like to have the radian, okay, because this semester, after we've done all of these things, and in the process, I want you guys to get used to radians. Well, knowing your background, some of you no degree. Some of you have taken trigonometry. Some of you have not taken trigonometry. Okay, I'm going to try to make it work for everybody. So I will make the best effort. But you can also see we have this, you know, array of different backgrounds. And some of you, even that person have taken trigonometry. This person might have taken trigonometry a few years ago. Okay, so how much is being retained? That's a question. How many of you have taken trigonometry like last semester or most recently? So if you could give me a report. You took it in the summer. Okay, that's good. Okay, so if you can give me some feedback on that about when you took it, right? Before, you know, how long ago, you know, semester ago, 2 years ago, and so on and so forth. That will help. It just helps me to how to structure the class so that I can help the most people with the most benefit, right? Even though it may not be attained. You see somebody take it 5 years ago, and then, but I'm trying to take care of everyone, okay? All right. So now you see the angles here. Hold on, I'm going to have to close this, you know, the Zoom stuff, right? So now this one is talking about the measurement. You see the angles are measured. Hold on, I need to share the screen, right? I didn't share this screen with you. All right, so look at this, right? Someone developed this software. It's called Math. I will send you the link, okay? I will send you the link. It's called reference angle. So smallest angle that the terminal side of the given angle makes with the x-axis. It has a definition here, but I'd rather use the textbook definition. So don't use this definition, okay? Don't use this definition, okay, you guys? don't use this definition. Just use a textbook definition because that's, use the textbook definition. So ignore this definition, okay? So now, all the angles measured from standard position. I want you guys to see that yesterday we did 4 examples, 4 cases, right? The terminal is in different, different quadrant. Do you guys understand what quadrants are? Do you guys know what quadrants?
Yes.
Okay, so this is the first quadrant. Cannot remember. So some people don't know what I've forgotten. That's okay. So this is the first quadrant. And this is the second quadrant. Okay, you can see the quadrants are measured from counterclockwise. Okay. And this is the third quadrant. We use Roman letters, Roman numerals. And this one is the fourth quadrant. Okay, when we were doing the whatever we have done before, we already did it, right? Those are the quadrants. I didn't realize some of you have forgotten, but now just to remind you, first, second, third, fourth. It's arranging counterclockwise. Okay, that's mathematics. Just to tell you a story, I don't know if you guys have read the book by Robert Kiyosaki. He talked about the quadrant. He wrote a book, Rich Dad, Poor Dad. Do you guys read? Anybody read that book? No? He talked about quadrants. And there's another occasion I saw someone study economics, giving a talk. They talk about quadrants. Okay, what the way they number it, it was a first one, second one, third one, fourth one, and this from that example, I can tell this person has not remembered much from mathematics. Okay, or he has his own idea about how the quadrants are arranged, but not in mathematics. In mathematics, when we arrange letters about polygons, we always go certain direction, either counterclockwise or clockwise. Okay, so that's the consistency. So in this case, the quadrant is a quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. Then you say, is it always? Yes, always. Okay, so these are the conventions. These are the conventions in mathematics. And the good news is that these conventions has been adopted by mathematicians, math teachers, all over the world, across the languages, across the nation borders. Okay, that's good, right? That makes it consistent. That's a standardizing. Okay, so with that said and done, I'm going to clean this up. So every angle for input of the trig functions are measured from standard position. So let's look at how you can find the reference angle. Okay, the reference angle from standard position. Okay, so you can play with it, right? That 0 degree. Do you guys see that? And the reference angle, the blue is the reference angle. You see in this case, the reference angle and the angle itself are the same. But what if I go around? Right? You add a 360 degree. It's still, you still have, now this time the reference angle and the angle is 410. The reference angle is what? 50. Is the terminal between, is the angle between the terminal and the x-axis and the smaller one. There's another angle. This one is obtuse. It's larger than 90 degrees, so that's not reference angle. So this is a case number 1. So we are addressing these case number 1. Okay, so now let's look at case number 2. If I measure this angle, then you can see obviously the reference angle and the angle 136 degrees, and the reference angle is 44 degrees. And the terminal, between the terminal and the x-axis, okay? between the terminal and the x-axis. Do you guys follow me? So I'm doing this because I want you guys to be able to speak the definition of reference angle. Could you please speak the definition of reference angle? Right? So now if I turn around, right? That's how you identify the reference angle. Reference angle is 40 degree, but the angle is 500. Now that's case number 2. Okay, case number 2 is when terminal is in the second quadrant. Number 3, measure from standard position, ended up in quadrant number 3, right? And what is the reference angle? The reference angle is the positive acute angle between the terminal and the x-axis. And this time the x-axis, this entire thing is x-axis, okay? So it's a 32 degree. We only take the positive number. You guys follow me? We only take the positive number. Now, what if I go around and round and round, I ended up here? Well, it's still, the reference angle is always, okay, is always the positive acute angle between the terminal and the x-axis. Can you guys speak it? Can you repeat after me? The reference angle is the positive acute angle between the terminal and the x-axis. Okay, I want you to reflect on those words. Reflect on those words. Okay, every word counts. Every word counts. All right, so that's case number 3. Case number 3. Okay, so now what if I start from the standard position and I measure and I terminate at quadrant number 4? What will be the reference angle? The reference angle is right here. Right? The angle is 328 and this is 32 degrees, right? So 32 degrees, it's just an example. It's just an example. Now, what if I measure clockwise? Of course I can measure clockwise, right? So round and round and round and round. Ended up in 4th quadrant. The angle is negative 1,464 degrees, and the reference angle is 24 degrees. So from this, you can see, what do we see in this process? What do we see in this process? What's the relationship between angles and its reference angles? I want you to think about it, okay? You guys could get on the website and to play with it. And we want to discuss what's the relationship between angles and its reference angles. Can we say something to summarize this observation? Summary. Can we say something about that? This way of thinking is called a study. This is a study. Okay, this is study. So what can we say? So let me write down the question. Do you guys understand the question? Okay, how about I send you the link, right? I send you the link to, so you can play with it. Let's go to Pronto, right? Pronto. I'm sending you the link. Play with that. Play with it. And what can we conclude about the relationship? Okay, so let's go back here. Now you can play with that link. Okay, we haven't get to D yet. Okay, we haven't get to D yet, but it's very important that we have some kind of understanding about the relationship between an angle, right? Angle and reference angle. What are the relationship between angle and reference angle?
Professor,
I'm sorry, go ahead.
did you want me to comment on that question you asked? Or?
Sure, go ahead.
So there, I see that no matter what the angle is, positive or negative, its reference angle is always positive, acute angle, and it makes between the angle is between the terminal and the x-axis.
Wonderful. Can you type that on the chat?
I try. I'm not good with typing, but
Okay.
I do my best.
Okay. No, this is a process I'm showing our students and all of us how to study. You really have to organize your thoughts. Okay, it's okay, Farouz. Okay, do the best you can.
Yes, okay.
Okay. When I was a student, I would have to do that. When I try to understand your question, I would do that. I have to contemplate your question to make sure I understand your question or your comment, your statement, in order to make a judgment call or answer your question. I think this is an attitude of living. Okay? If you don't understand the question, you certainly cannot answer it properly. So first, you make sure we understand the question, right? And to understand this question, oftentimes we verbalize it, right? We take time to verbalize it. Okay, so while Farouz is typing that, I'm going to make a couple comments. I want you guys to think about it. Okay? Every angle, okay, of course, measured from every angle, I'm going to call it A. I'm going to call it A. Imply that this angle is measured from the standard position clockwise or counterclockwise, any way you measure it. Okay, so that's what it implies. Measured from the standard position counterclock, we counterclock or clockwise okay, that's what this angle is about. Every angle has a unique reference angle. Which is positive. So I'm reciting positive acute angle. I'm citing the definition of reference angle, which is acute, positive acute angle between the terminal and x-axis. Okay, this is my first statement. Do you agree? I want you to read it carefully and change my grammar, change it, whatever, okay? Improve my Chinglish. And I'm copy and paste Farouz's statement. I'm going to put it on the screen. no matter what the angle is, positive or negative, its reference angle is always acute positive and is between the terminal side and the x-axis. Okay, so this is Peru's statement. So I'm going to call it statement number 2. Statement number 3. So any one reference angle. So this is the word I'm using. A reference angle may be the terminal of a reference angle. Okay, the terminal of a reference angle is a terminal of many angles. Or I can even say infinite number of angles. Do you guys agree? So we have these 3 statements. Okay. What we just did, right? Are you guys playing with that reference angles? Right? Each reference angle, each terminal, we should have once the terminal is fixed, the reference angle is fixed, right? But this terminal could be the terminal of many angles. Do you guys agree with me? So I want you guys to read these 3 statements very carefully and reflect on the definition and reflect on your practice that we just did, something we just did. And this is called summarizing, observing, and studying this process. And you're going to be very patient with yourself. You take your time. You take your time. You want to make sure all these, getting into your mind, you understand it. You understand it. Any questions so far? So this is regarding reference angle. Any other comments anybody wants to make? I would ask you to put it on chat, and we're going to copy and paste and put it on the screen. You guys follow me? So far, so good? So understanding this concept is absolutely important. It's absolutely important because we're going to be using this concept. We're going to be using these concepts over and over again, over and over again. All right, any other contributions from you about the comments of reference angle? As I said, I will be using radians as much as possible. Okay, I don't understand how an angle can have unique reference angle. I don't understand how an angle have a unique reference angle. All right, that's a good question. New share. Okay. You see this angle, 145 degrees? What is the reference angle? The reference angle is between the terminal and the x-axis. It's a 35 degrees. According to this definition, do we have another one that we can call a reference angle? Do you think we can have another reference angle? 445 degrees? Yes, which one? Which one? This is the terminal, right? Between the terminal and the x-axis, there are two angles. One is a 35-degree angle, and the other one is this one. Right? Do we have another one? Which one of these two angles is a positive acute? The 35-degree, right? The other one is more than 90-degree, it cannot be acute. Right? So the definition is already ruled this out. So the only one we have is 35-degree. Do you see that? Right? Good. Anybody else? And then you try another terminal. You try another terminal. Right? Do we have another reference angle? There's only one. It's for each angle, there's one. Right? But not the other way around. Okay? Not the other way around. That's what I'm trying to say. Okay? So what do we have studied here? These two statements, right? So if you have an angle, A, right? And the other side, you're going to have reference angle. Reference angle. From angle A to reference angle, that's a one-way street. It's unique. It's unique. How about the other way around? If you have a reference angle, how many angles you could possibly have? You could have as many as you want, right? Do you guys follow me?
Yes.
Do you guys see that? Otherwise, we'll go back to the picture.
Yes, we can have infinitely many angles.
You guys see that? Do you guys see that? Okay, so let me show you. For example, if I decide this is my terminal, okay, this terminal has the reference angle, which is 35-degree. Okay, so what I'm going to do is I'm going to draw this terminal. I'm going to leave it there, right? Okay, and now I'm going to draw another angle. This angle is 505-degree. It has the same reference angle. Do you guys see that? Yes, do you guys see that? Yes?
Yes, yes.
Now, if I draw another angle, I draw a negative angle. It's a negative 215-degree. Negative 215-degree has the same reference angle, 35-degree as well. And I can keep this process going as long as I wish. Do you guys follow me? That's what we meant. Do you follow me? And that's the meaning of statement number 3. So now, do you agree or not? Do you agree? Right? From any angle, the reference angle is one and only. But The other way around, you could have many, many angles for the same reference angle. And all of these angles together, we call them, they have a co-terminal. They have the same terminal. Okay, they have the same terminal. Okay, so if you know the reference angle, you need to understand for this reference angle, okay, there are many, many angles that measure from the standard position. They could be counterclockwise, clockwise. Do you guys understand? I want you to vision that. It's very important that you vision that. So the other way around is not unique. So for example, okay, let me give you this question. Okay, I have a question for you. For reference angle of 40 degrees, okay, I'm going to use a non-special angle. Give me some examples of angles A, okay, whose reference angle is 40 degrees. From terminal in every quadrant. In every quadrant. In every quadrant. All right. Okay, so I'm going to give you a picture to help you to see this. Okay. The reference angle is 40 degree. You guys know? 40 degree. So from 40 degree reference angle, okay, I'm going to use green. Okay. Suppose this is 40 degree. This is reference angle. Okay. And this is also 40 degree reference angle. And this is also reference angle, 40 degree. And this is reference angle, 40 degree. Okay. So I will make sure all of these is 40 degree. $40 degree. 40 degree. Oh, this is just so ugly. Okay, let me do it again. Too crowded. Okay, I don't like it. Okay, 40 degree. Okay, reference angle 40 degrees. So I'm going to do this again. I want you guys to give me examples. I want you guys to give you examples. Give me examples. Give yourself examples. Okay. Of angles that terminates on all these different terminal. 40. 40. Okay, this is a 40, this is a 40, and this is a 40. How are you going to find those angles? How are you going to find those angles? Okay, one person says 140. 140. So let's see if that works, right? That angle has to be measured from the standard position, terminate on one of these. And what is the angle measured from standard position, terminate at 40? It would be 180 degree minus 40, right? So this is 140. Good job. You got it. More. Could there be another one here? This is going to be what? Oh, someone gives 320. That's right, 320. How do you measure 320? You go this way, right? Oh, 320. Right? Do you guys see that? It could be negative too, but all of these angles are measured from standard position. How many can you give me? There are infinite number of them. You just have to go there and find them. So we got 2 examples. I want to have 5 more. Should we exercise on this, Farouz? Do you think we should exercise? Because I think this is very, very important to understand this.
It's a good idea, Professor.
Okay, guys. I'm going to have a breakout room. Okay? Each one of you need to give 4 examples. Each one terminate in each quadrant. Okay, so let's do the breakout room. Okay, you already see some examples. What are we doing here is deepen the understanding of the definition of angle. I'm at the angle measurement, reference angle. That's the target. That's the target. Okay. So breakout room, let participants choose voluntarily open all rooms. Go for it. Okay. I want you guys to give those angles. Okay. So 40 degrees. Okay, 40 degrees. Okay, all these 4 has the same reference angle, 40 degrees. Does everybody understand the question? Okay, each one of you need to come up with 4 angles on each quadrant, terminate on each quadrant. You can go around and round and many times you want. You can do positive, you can do negative. Okay, and your answer, you can put it on chat. And we're going to judge whether that's correct. And soon enough, you're going to develop a technique, right? You are going to develop a technique to find those. So I'm going to give you kind of 5 minutes. Anybody could ask a question right now. Since any angle in the first quadrant is its own reference angle, I like that language. Very good job. Angle shouldn't, angle wouldn't that makes 40? Yes, absolutely. You are absolutely right. Could you guys look at the comments by Olamite? She's right. 40 degree itself can be an example. Don't forget. This one can be 40 degree. Yes. But 40 degree plus 360 degree, it will give you another one. Do you guys follow me? Do you guys follow me?
Oh, yes, we are, Professor.
You see, I want you guys to identify those other angles with the same reference angle. How many can you find? Infinite. Could you guys look at the comments by Olamite? Did I say your name correctly?
Yeah, you can just say Ola.
Ola, you are absolutely right. You are absolutely right. That's in half first quadrant. But there are many more angles that could terminate in the first quadrant, right? It could be 40 degree plus 360 degree. 40 degree plus 720 degree. The list could go on, right?
Yes.
You see? Someone just identified 140 degree. How about 140 degree plus 360 degree? And you get another one, right? Yes? Is that fun? Lots of answers, many answers. Okay. Okay, Ola, can you do a favor for me? Okay. I want you to change your sentence that you posted on chat and use affirmative words to confirm, because now we have discussed that you think you're right. Can you write in the language of affirmation on chat? And I want everybody to write it down.
Okay, no problem.
Thank you. Good job. We ask questions and we answer the questions and we summarize and we conclude. Right? Look at that answer. I want everybody look at the example by Ola. Okay. He said 400 degrees. So he took 40 degree, add 360 degree, right? Is that what he did? And he got 400. Okay. And he gave a negative angle on quadrant 2. Okay. You measure from the standard position that negative 180 and add a negative 40, you add a negative 40, you get a negative 220. That's wonderful. Quadrant 3, you measured counterclockwise, get 220. Wonderful. Quadrant 4, negative 40. Any angle that terminates in the first quadrant would be its own reference angle. That's a wonderful summary. Wait a minute. Any angle that terminates in the first quadrant would be its own reference angle. You know what? I don't agree. I don't agree.
You don't?
I don't. You have provided the example.
Okay.
400 terminate in the first quadrant. But but it's not the same as reference angle. Reference angle is 40. Read your sentence again, Ola. Any angle that terminates in the first quadrant would be its own reference angle. What does that mean? From what I read, you said that 400 degrees reference angle is 400 degrees. Is that what you meant?
Hello. Let me reiterate that.
I'm sorry?
I'm gonna reiterate that. I'm gonna rewrite it.
That's right, because you have a counterexample for yourself.
Yeah, I see my mistake now.
That's right. Very good. Very good. You see, this is a process we do. We patiently working with ourselves and with our classmates, with our teachers. You make those statements, you understand the statement you make, and you constantly modify it until it is perfectly right. You will need to do this every single day from now on. And mathematics train you to do that and do that better. Because you're making a very general statement. It has to be true all the time. False once, false. Right? False once, false. All right, so I'm going to call it off. Okay, I'm closing the room. I hope Farouz agrees with it. Ola, you need to, if you want to work on your original sentence, you can, you just need to add or subtract some words. But if you want to create something new, that would be totally great. Okay, just keep trying.
Yeah,
You're on the right track. You're on the right track. Okay. So this is what we practice. We're practicing using our words to enhance our understanding. We critique ourselves until we get it right. Until we get it right. It's a process. It's a process.
We are all back, Professor.
Oh, right. Welcome back. Okay. We had an example in our room. Can we have someone give us an example from the breakout room? You know, the example just like, oh, that's from Christopher. I'm sorry, that's not from Ola. Okay, you see Christopher gave an example of terminals in each quadrant with reference angle, which is 40 degrees, and he is completely right. Okay, I just want one example from someone in the breakout room. Could I have that contribution? The example is on chat. Okay, follow Chris' example. He did a perfect job. Okay, those examples are right. But your example should be different from his. Okay, that's what I'm asking you. Your four angles must be different from Chris, for example.
So, Professor, with the same reference angle 40 degrees?
Yes, absolutely.
Okay.
We're going to wrap it up, but we're going to have a closure.
So
okay.
we can go beyond one complete revolution. Is that what you mean?
Oh, certainly. As many as you want. As many as you, that's the whole point.
Yes.
Okay, did you guys see Chris? Oh, Chris, give it only to me. Sorry.
Yes,
Sorry, Chris. Okay.
I couldn't see the chat.
Okay. Chris' example is right here. Okay, do you guys see it now?
Yes.
I'm sorry, Chris. Okay, got it, Chris. So now Chris put it on to everyone, but you can also look at the screen. Okay. These are the 4 angles that Chris gave to us. And he's completely right. You guys can check it. Okay, I'm just going to add the degrees because the software doesn't add that degrees for him. Okay. Do you guys want me to go over these? Because I have a specific requirement. Your answer cannot be just a simple repeat of Chris' choices. Your answer have to be completely different. Also from each quadrant, right? So this is a Chris work. Your example have to be different. Good job, Chris. I just need one more. Oops, sorry. Q1, Q2, Q3, Q4.
$140.
140 degree. For quadrant which?
140 degrees, second quadrant.
Second quadrant. 140 degrees. Does that work? Oops.
If the reference angle is 40 degrees.
Yeah, we're talking about the reference angle is a 40 degree for sure. Okay, we're not going to change that for.
Yes, so reference angle 40 degree, that would be good for second quadrant.
$40 degrees. I saw 60 degree quadrant 1. Is 60 degree has a reference angle of 40 degrees?
So we can check it real time. It is acute angle, it is positive, but it is not same as the 40. So that.
What is the reference angle for 60 degrees? You use the software I give you. You use the link I send it to you. Yes, 60 degree is in first quadrant, but its reference angle is not 60. Its reference angle is 60, not 40. Do you guys follow me? You measure 60 degrees. Okay, from the center position, you measure 60 degrees. It is in the first quadrant, all right? But what's the reference angle? It's a 60 degree itself. Okay. All right. So someone give the answer 40. Yes, 40 will work because the reference angle of 40 degree is 40 degree. Do you guys see that? If this angle is 40 degrees, okay, I'm going to start over. We measure the angle from standard position and we measure 40 degrees. What's the reference angle? That's right. Okay, so 60 is not the right answer. 40 is. Now, with that reference angle. Where are we? We get an angle for quadrant 1. We get an angle for quadrant 2. Can you give me an angle for quadrant 3, which is different from 220?
580 degrees.
How did you get that, Farouz?
I added just one complete revolution, 360 degrees to 220 degrees.
Did you guys hear that? If you are certain 220 degree, okay, so let's go back there. So let me put the answer, Farouz's answer. Farouz's answer is what? 600 what?
580 degrees.
580 degrees. $580 degrees. Okay. Now, what's the reference angle of 520 degrees? I'm going to measure from the standard position 520 degrees.
580 degrees, Professor.
580 degrees, sorry, 580 degrees. What's the reference angle?
Bingo, 40.
Do you guys see that? Does everybody see that? Is that reference angle 40 degrees? Terminating the quadrant 3. Does everybody get it now? Kind of. Do we still have, it looks like we still have questions. Yes? Do we get it? So is 580 degree the right answer? 580 degree, is that the right answer? It is, right? Thank you, Farouz. Can we
Sure.
get another answer in quadrant that terminates in quadrant 4? And Vincent gave 230 degree in quadrant 4, quadrant 3, sorry. So I don't want to overlook that. And I want to use Vincent's answer. Could you guys tell me, is 230 the right answer? 230. Start from 230. From standard position, we measure 230. The reference angle is what? Is 50 degree. Ah, he corrected himself. Wait. Okay, he corrected himself, 220. But then your answer is the same as, the previous one. You have to come up with a different one. Right, you have to come up with a different one. Try again. Please try again. I'm going to quiz you guys on this next week, not this week. This week we already have 3 quizzes. So next week I'm going to have a question about these. Okay. All right, I'm already contemplating the questions on the quiz. All right. 580. And there are many more. Quadrant 4. All right, Kelly gave an answer for 680. Let's see, 680. Let's see if Kelly gets it right. 680 degrees. $680 degrees. Okay, let's measure 380 degrees. From the standard position, everybody, that's the point. Okay, from 300, We're gonna measure 360 degree, I'm sorry, 680 degree. 680 degree. All right, are we getting closer and closer? 380 degree. Is Kelly correct?
Yes.
Yay, she got it, right? You guys are giving me a bunch of positive angles. Could you give me some negative angles? 320. Right, that's a 360 minus 40. Yes, absolutely. All right, so we're gonna stop this exercise. Do you think? I think everybody got it, right? Can I say that?
Yeah.
Okay. So now I want you guys to read the statements again. Okay, so I'm gonna put the answer 320 for the record. Okay, so this exercise is over. So now I want you guys to read the three statements one more time. I want you guys to read the statement one more time, okay? I'm gonna ask some people to read these three statements. Could I have some people read this statement? Noah, can you read those statements? Can you read the first statement for us? No answer. Bodhi? Where's Bodhi? Where is everybody? Ola.
I'm here.
Okay, I know Farouz is there.
Hello?
Ola, can you read the first statement for us?
Okay, every angle A measured from the standard position counterclockwise or clockwise has a unique reference angle which is positive and an accurate angle between the terminal and the x-axis.
Thank you. I'm sorry, Paul, for my typo. And the word you read here is called acute. Acute. Okay. Thank you, Ola. Second statement. Chris, can you read the second statement for us?
No matter what the angle is, positive or negative, its reference angle is always acute, positive, and it is between terminal side and the x-axis.
Wonderful. Wonderful. We got Ola, Chris, Noah. Is Noah there? Can you read the third statement for us?
The terminal of a reference angle is a terminal of many infinite number angles.
Very good. Thank you so much. Okay. I want you guys to think about this because this reference angle is a single important concept, right? You can see I talk about all the questions you're going to encounter in Trig. They're either from A to D or D to A. And you can notice that R is what? R is the bridge. The reference angle is the bridge. I'm going to show you how it is a bridge. So if you could just focus on these three, you will be invincible. You can deal with any angle, any special angle, non-special angle, no problem. Now we have come to definition.
Professor?
Yes.
Yeah, so I reconstructed my sentence for the angles determined in the first quadrant. I put it in the chat. Could you check it?
Oh, sure. Which one? Let me see. I'm sorry. It just flew up. Is this one any angle?
Yes.
Okay. Thank you for reminding me. I apologize. Any
you're
angle
fine.
that terminate. I want everybody read Ola's message at 12:13. Is that right?
No, 12. Yeah. No. Oh, I think it's 12:11 actually. Yeah.
12:11.
Yeah.
At 12:11. At 12:11, that's a Chris answer. I'm looking at the chat. You are Ola, right?
Yeah, that's me.
I'm looking at, there's one statement at 12:13.
Okay, could you read that? Let me hear it.
Okay, let me read it. Any angle that terminates in the first quadrant will have its reference angle between 0 degree and 90 degree.
Oh, yes, that's it.
Yes. Any angle that terminates in the first quadrant will have its reference angle between 0 degree and 90 degree. That is correct. That is correct. Okay, very good job. Very good job. I hope you guys all have witnessed this process. We're going back and forth, right? And along the process, in the process, your summary will be getting better and better and better yet. Okay, and you are speaking the language of mathematics in the process. All right, so without further ado, let's get to the definition. This is the exciting part. Okay, these definitions I will call, remember we talk about function is a rule, right? Okay, these definitions basically is a rule of functions. And because these are the rules of functions, in order to explain the rule of this function, okay, we're gonna have to set a stage. We're gonna have to set a stage. We're gonna set a stage. So you can see the rule of function is getting more and more complicated from the first one in basic one until now. Okay, so now we start to talk about the rule of function, sine, cosine, tangent, cotangent, secant, cosecant. Could you guys tell me what was the definition you have learned? What the definition you have learned about these functions? Sine of an angle. Sine of an angle. Cosine of an angle, for example. Can you guys tell me the definition you have learned before?
Professor, I can give an idea so a student can get more ideas if you want.
Sure, go ahead.
So sine of any angle like A is equal a ratio of its opposite side to hypotenuse in a right triangle.
Which triangle?
Right
You talk
triangle.
about any angle. Which triangle? Which angle?
Angle is A, right? For example, if you have a right triangle ABC, C is the 90 degrees angle. So A could be any of the other two acute angles. So sine A, sine angle A is the ratio, which is a fraction, which numerator is opposite over hypotenuse. Opposite of what? Opposite side to angle A, to hypotenuse of that right triangle.
All right, that sounds like a bunch of description, right? That's a bunch of description.
Yes, and the abbreviation shortcut is exactly what you are writing it, opposite over hypotenuse for the sign.
All right, very good, very good.
Thank you, Professor.
Okay. The definition of trig functions actually is first you have to set the stage. You have to first you set the stage. Okay. So I'm going to type the words. I'm copying these words directly from the textbook of trigonometry. And I want you guys to write it down with me. Okay. And this is the stage set. Stage set. Any one of you like to perform, you know what stage set means, right? Yes? Do you guys understand what stage set means? You have to build a stage. So here it is, definition of trigonometric functions. Okay, listen up. You might not have paid much attention to this definition. But to me, this definition is super duper important. Okay, I'm going to show you. Okay, now, if theta, okay, I'm going to use A because A for angle. Okay, the A I'm using here is going to specifically refer to angles measured from standard position. We already have A and R already, right? We have A and R already. I want you guys to have those carved in your head. Do you guys follow me? We have spent so much time to study A and R, and we do that for this moment right now, right here, right now. Okay, if A is an angle, okay, in standard position, I would say is an angle measured in standard position, measured from standard position. Okay, and a point x comma y on the terminal side of theta. Okay, then I'm going to use A. On the terminal side of A other than the origin of A other than the origin. Okay, so why do you want to mention other than the origin, right? I want you guys to pay attention to that. I'm just showing you how to study, really. I'm only just showing you how to study. Okay, an angle is A is an angle measured from standard position, and a point x comma y on the terminal side of A other than the origin. Right? You cannot pick a point on the origin because every angle, right? The terminal will start from the origin. You cannot pick origin. Do you guys understand? This sentence, okay, we have more to come. This sentence is referring to what? This sentence is referring to what? This sentence is referring to okay, this sentence referring to what? So you measure your angle from the standard position. You could measure any way you want. And you have a terminal. The terminal could be anywhere. And you pick up a point on the terminal, any point other than the origin. And what are the possibilities? Tell me, what are the possibilities? Your terminal could be here, and you pick a point here. And your terminal could be there, and you pick a point there. Your terminal could be over here, and you pick a point right there. And your terminal could be over here. Oops. And your point can be here. Do you guys follow me? So this sentence tells you all these possibilities. And you cannot pick the point at the origin. Do you follow me? Not this point. Not this point. This point is on the terminal because this point is on the terminal. You cannot pick that point. You follow me? That's what it says. So you read this sentence, you want to be able to draw the pictures to understand all the possibilities. And this is how you study mathematics. I'm showing you. You carry this method with you. When you are in calculus class, you keep doing that. You always ace every class. Okay. Now, let's read the rest of it. Okay. And all of these points, we have a name for them. They have an x coordinates, they have a y coordinates. They have an x coordinates, they have a y coordinates. They have an x coordinate, right? Y coordinates. You have x coordinates, you have a y coordinates. You have all these possibilities. You guys follow me? Tell me, what's the meaning of x? What's the meaning of y? Basics. What is the meaning of x? And what's the meaning of y? For this first point, in the first quadrant, what is x? What is y? I want you guys to draw the picture with me, okay? Everybody. What is x? What is y? For this point, input, output, that's right. That's right. But how do you measure them? Right? The input, for x, this is how long it is. And the y, that's y. So this is x, this is y. Do you follow me? This green is x, the red is y. How about for this other point? What is x, what is y? This is x, that is y. Okay? This is x. For this third point on the third quadrant, this is x, and that is y. You follow me? And for the last point in the fourth quadrant, and this is x, and that is y. Okay, guys? If you don't study this way, guess what? Your homework will make you do that. If you look at the homework in the back of each section, your homework will guide you to do it this way. I assure you, every textbook is written that way. In mathematics, at least. Right? They will give you all these cases you have to work with. All right? So just this one sentence. Have we got it on the stage? This is the stage set. This is the stage set. Okay? Let's see what comes next. And then it comes the definition of trigonometry. Okay, then it comes to the definition of trigonometry. Okay, so did you guys write them all down? Because I'm going to clean this up. Input, output. Do you see? Hazel put in there, right? What did we talk about from the beginning of the semester? A function has input and output, right? Input related to domain, output in range. When we talk about the rule of the function, now we're going to have a new rule. The new rule, let's see what the new rule. The new rule will not be the XY input output will be different. Okay, so let's see. Isn't the class technically over? I think we get to 12:50. Yeah.
We have like 12 minutes left, Professor.
Okay. We still have 9 minutes left, right?
Yes.
Okay. So next, let's look at the definition. Oh, wait. Okay. So I'm going to put this table here. Okay, I'm going to put this table here. Okay. I hope I don't have, well, you know, it's a mess. So I'm going to just clean this up. Okay, I'm just going to clean this up. Now, sine of A is equals to what? Sine of A is y over r. Cosine of A is x over r. Okay, we know r is the, you know, r will be specified, okay? R is specified. So we know what x is, what y is, right? So r is what? The square root of x squared plus y squared. And from here, you also understand why we cannot pick the point at origin, because at the origin, r will be 0, right? And we'll be dividing by 0. We cannot, we don't allow ourselves to do that. And tangent A is y over x. Cotangent A is x over y. Cosecant of A is r over x. R over y, sorry, r over y. And secant of A is r over x. Do you guys see the stage set now? Do you guys see the stage set now? Okay, so the stage is set. So this definition, and these are the rule of functions, right? So let's look at the rule. Now, did you guys just mention input output, right? X comma y is the input output in some certain sense. However, if you look at the rule of the function, okay, I'm going to add one more column. What kind of rule is that? Sine function, the input is angle. It's A. You guys see that? The angle, how do we find that? Right? Suppose we have an angle in the first quadrant. This is a terminal, right? Let me change the color. Okay, this terminal, right? And you pick a point. Makes sense in a meeting. Okay, I'm not going to that meeting. Sorry. You pick a point, and this point is XY, right? And this point is X comma Y. That's what's inside the definition, right? And what is R? The hypotenuse, right? Because we just talked about this piece. This is X, right? This is X, this green line, this height is X, right? And what's the Y? This is Y. So this is X, and the red one is Y. Okay? This is Y. I'm sorry, can you guys see the X? And what is the R? This piece is R. The hypotenuse is R. You can see that stage set. Do you guys see that stage set? Every symbol is specified clearly. Okay. Sorry, close that reminder of attending meetings. Anyway, and then you see what happens, right? And this rule, this new rule of function goes like this. Sine of A, this angle is A. Okay, this blue is A. And let's see what's the output. The output is a ratio. The output is a ratio. The output is a ratio. What kind of ratio? What kind of ratio? Now it comes to the opposite over hypotenuse. Do you guys see that? The opposite over hypotenuse. In your geometry class, you're dealing with just triangles. Now, all those triangles now, all those right triangles now is going to move into the rectangular system. So they're being digitized. Okay, I think digitized is the right word because now every corner, every angle, every, all the sides or all the angles, they have a position. That's called digitized. So trigonometry is digitized some aspect of geometry. So this is the new stage set. This is the new stage set. Are you guys with me? I want you guys to I want to put you guys on the stage. When you think about these pictures, so this is A, this is R, this is D. I'm not telling you to forget about your old definition. But you have to understand from this one definition, we can derive so much. Just focusing on the definition. I'm going to show you how. Okay. And we shall continue tomorrow. Okay.
Thank you, Professor.
Thank you.
See you tomorrow.
See you tomorrow.
Thank you, Professor.
Thank you. Very good job. Very good job, everybody.
Thanks for the lecture, Professor.
Of course, my pleasure. Good job, you guys. It's a great pleasure. Thank you, Vincent. I can't wait. Okay, see you tomorrow.